Today we are going to start with the new chapter, that is work energy principle. Okay, so first of all we will see the topic work, then what are the different forces by which work can be done, then we will study the energy, and then we will try to correlate the work and energy principle, and lastly we will see the concept of power. So the first topic is work. Okay, so what is work? So we all know work or work done is the product of force and displacement. It is the product of force and displacement. Okay. Let's try to understand this concept. Suppose this is a horizontal surface on which a block is resting. So its initial position is 1 and we are applying a force in this direction. Now due to this application of force, this block is get displaced to the position 2nd, and let's suppose this displacement is S. Okay, so this displacement occurred due to the application of this force F. So this overall event is considered as work done. So work done is equal to force into displacement. Now the unit of work done. Okay, so we know the work done is the force into displacement. What is the unit? What is unit for force? Force unit is Newton, right? And what is the unit for the displacement? It is meter. So the unit of work done is equal to Newton meter, or we can write it as a joule, right? If suppose inclined force is applied to this block, let's suppose this force F, which is inclined at theta to the horizontal. Now this is the position, first position. Due to the application of this force, this block get displaced to the position 2, and this displacement is, let's suppose, S. Now in this, what is work done in this situation? Okay, now to find the force work done, we need to resolve this force into two components, that is X component and Y component. So the X component is F cos theta and the Y component is F sin theta. Okay, now which force is causing the displacement between these two, F sin theta and F cos theta? F cos theta. Okay, there is a force F sin theta, but in the Y direction there is no displacement. Okay, you can see, suppose this is the bottom line, so here it is your object, and here also at the same level this object, means there is no displacement in Y direction, but there is a displacement in which direction? In this direction, that is in X direction. So F cos theta force is applying forces, due to this force work is done. Okay, so how we can write? Work done is equal to F cos theta into S. So we can write this F as cos theta. Okay, so what is this? It is a F vector dot S vector. Okay, so we say that work done is a scalar quantity. We can also find the work done by the graphical method. Okay, let's suppose we draw the graph for the force versus displacement. Okay, now let's suppose force is constant. Okay, and this is the initial position S1 and this is the final position S2. Now for this, what is work done? So work done is the area under this force displacement curve. area under the force displacement curve, that is work done. And if suppose there is a variable force, means what? As the displacement increases, force increases. Okay, so in that also work done is area under this curve. Okay, so we can write work done is equal to, okay, so there is a displacement from S1 to S2 into ds. So this is the work done in the variable force. Simply what you can say, graphically the work done by force can be represented by the area under force displacement diagram. Now the next topic is work done by different forces. As there are different forces like constant force, variable force, frictional force, gravity force and spring force. Okay, so due to these different type of forces, there are different types of work done. So we will see in this topic what are the different types of forces. Okay, so the first is constant force. So we'll understand what is the work done by the constant force. Now we'll take the same example. This is the block which is at initial position 1, and we are applying the force F, and due to the force F it get displaced and it will get now the position 2. This displacement is suppose S, and in this condition what is work done? So work done is the force into displacement, that is F into S. Now let's suppose there is a force acting on a block which is inclined at angle theta. The initial position is 1 and the final position is 2. The displacement is S. This is force F. So in this condition, what is work done? So work done is F cos theta into S. Right? Now we will see the different condition in this, means different angle. Suppose theta is equal to 0 degree. Okay, so if you put theta is equal to 0 in this, so what is work done? So work done is F cos 0 into S. So what is cos 0? Cos 0 is 1. So it is F into S. So what this says, theta is equal to 0 degree. Okay, theta is equal to 0 means force is horizontal. Okay, if suppose force is horizontal and displacement is also horizontal and in the same direction, force and displacement if suppose in the same direction, then work done is what? Positive. When theta is equal to 0, work done is F into S. Right? If suppose force and displacement in the same direction, then work done is positive. Remember that. Okay. Now the second condition is when theta is equal to 90 degree. When theta is equal to 90 degree. Okay. So what is work done in this case? F into cos 90 into S. What is cos 90? Cos 90 is 0. So in this condition, work done is 0. Okay, so what this means, okay, if suppose force direction is this and displacement direction is like this, okay, means there is a no displacement. Okay, as you can say in this, so the displacement is due to this horizontal force. Okay, but there is no displacement in the y direction due to this vertical force, means theta is 90 degree. So in this condition work done is 0 due to the theta is equal to 90 degree. And third condition is theta is equal to 180 degree. Okay, so theta is equal to 180 degree. So work done is equal to F into cos 180 into S. So what is cos 180, it is minus F into S. Means what? Work done in this case is negative. So how it is? If suppose force we are applied in this direction and displacement is in the opposite direction, okay, then work done is said to be negative. Force direction and displacement direction is suppose opposite, then work done is said to be negative. When this is possible? When theta is equal to 180 degree. Now the second type of force is variable force. So what is variable force? So if suppose we are applying 5 kilonewton force to this block and this block is get displaced. Throughout this displacement, if suppose this force is constant, then this force is called as constant force, okay. But if suppose force is variable throughout this constant, means suppose force is equal to, the equation is something like this, 5x square plus 2xy, okay, means what? The force is changing with respect to displacement, then this force is called variable force. For example, we will draw the graph so that you can understand. So this is the force and this is the displacement, okay. Now the force is changing, suppose it is increasing with respect to time, sorry, with respect to displacement, and then this force is called variable force. So in this condition, what is the work done? So work done is equal to, we need to take the integral. Suppose we need to calculate the work done from the displacement S1 to S2, okay. Then graphically it is the area under the curve, okay, and by the formula work done is equal to integral with the limit S1 to S2 F ds. So this is the formula for the work done by the variable force. Now the third case is work done by the frictional force. Again we will take the same example. A block is resting on a horizontal surface and we are applying the force here. Due to this force, this block get displaced from position 1 to the position 2. This is the displacement. So in this, during this event, so frictional force is acting in this direction. Suppose this friction force is Fr, okay. So we know the direction of friction is always opposite to the direction of force, that is direction of motion, okay. So direction of friction is like this, okay. So in this condition, what is the work done, okay. So we know work done is equal to F cos theta into S, right? Here what is F here? It is frictional force, okay. Cos theta, here theta is, if suppose direction is this is 0 but direction opposite, so it is 180 into displacement, okay. So what is 180? It is minus, so minus Fr into S, okay. So remember that work done by the frictional force is always negative, okay. So this we can also write by minus mu k into n into S. So this is the work done by the frictional, okay. Mu k, what is mu k? It is the coefficient of friction and n is the normal force. This is the mu, n is the formula for friction force, okay. So this is the work done by the frictional force, and remember work done by the frictional force is always negative.